Hello everyone, this is Mrs. Padmashri from SNS College of Engineering, Coimbatore. I am going to explain the basic concepts of machine learning. So, what is machine learning? Machine learning is a branch of artificial intelligence that enables the computer to self-learn from training the data that will allow the machine to think automatically without being explicitly programmed. And also, it improves over time without being explicitly programmed. So, this is the proper definition of what is machine learning. So, the machine learning concept is introduced by Arthur Samuel. He is an American. He is in the field of computer gaming and AI. Introduced machine learning in the year 1959 at IBM. So, the field of study that gives the computer the ability to learn without being explicitly programmed is called machine learning. So, then the question will arise how to construct the computer that will automatically improve with experience. So, that we will discuss in the coming slide. This is an overview of machine learning. So, the diagram which we are seeing is deep learning. Deep learning is a subset of machine learning, and the machine learning is a subset of artificial intelligence. So, the machine learning is derived from the artificial intelligence. So, artificial intelligence is a technique which enables the machine to mimic like humans, and machine learning, as we already discussed, is a subset of artificial intelligence that uses the statistical method to enable the machine to improve with the experience. So the deep learning, it's a subset of the machine learning which makes the computation of multi-layer neural network feasible. So in this overview of machine learning, we are going to focus only about the center part, the machine learning, which is derived from the artificial intelligence. So this picture is asking, a human is asking the question to the machine, I can learn everything automatically from the past experience. Yes, the humans can learn everything from the past experience, even if we make any mistake in the past. But now what we can do with that experience, we can try to correct ourselves. So that is possible in the human beings. Whether this is this possible in the machine, that will be a big question mark. But nowadays, the recent trends, the machine also can learn from the past experience with the help of machine learning. So here the picture depicts that the robot is reading a book. So machine can also train with the past experienced data. This picture depicts about what is the machine learning. So the machine that learns automatically, that can able to learn automatically from the past experience without being explicitly programmed. This is what a machine learning. So this is a diagram where we can see, it's a block diagram. We are going to give input the past data to the machine learning algorithm block, which is that we are training the machine with some algorithm, learn from the data, then machine will build a logical model. Whenever we give any new data or anything new to the machine will be giving you the output. This is a block diagram to understand how the machine is trained. Machine is trained with the past data, learn from the data, and the machine is going to build a logical model. That is, when we feed any new data, it is going to give you the appropriate output. So there are different scenarios in the machine learning. Scenario 1 explains about playing chess with a computer. This is a very good example for machine learning application, playing chess with a computer. So it uses the concepts of deep neural network. Concepts of deep neural network, that is, the neural network are trained to evaluate the position and predict the best move. Okay, MCTS algorithm is used in this playing chess with a computer application, is used to search the best move by simulating many random moves from given position. And also the reinforcement machine learning concept in the field of machine learning is used for generating the penalties in the environment to learn and emphasize the self play in the game. Okay, so here playing the chess with a computer is one of the best scenario for machine learning. The next scenario that we are going to see is a smart air conditioner. What is the smart air conditioner? In our home, we all will be having the air conditioner, but nowadays the new recent technology from the machine learning is a smart air conditioner, which means the system that learns how often a room is occupied based on the time, movement, etc. So here, this smart air conditioner, it's a smart saving technology, power saving technology we have, and it has a smart remote also. It turns your mobile into remote for the convenient access. So we can access the air conditioner through our mobile, and also it has the another thing, that is a smart sensor. It senses the ambient temperature and suggests the best mode. So air conditioning preferences learn from the past data. Okay, and it sets the temperature, and it also train the it also the air conditioner also trained from the past experience, like which month or day which is most demanding for the air conditioner. Usually we will turn on the ACs during the month of May, like that. Okay, so the machine will learn, according to that the machine will learn. Okay, so this during the month of May, air conditioner is turned on, so there will be a most need during this month. So it automatically learns from the experience, and whenever when the temperature is more, when the temperature is hot, it automatically turns on. So this is a very good scenario, or we can take it as an example for the machine learning. And the next scenario we are saying is a self-driving car, which is a autopilot mode. This is also an application of machine learning. And we here, the next picture shows you inside a home, all the electronic appliances are connected through the wireless mode through one modem. So we can able to connect all the devices through our mobile. This is a smart devices is one of the application of the machine learning. Next, we all know that the robot, we call this robot as Sophia. So whatever, like same like Google, whatever questions when we ask, she will be able to reply it. And now what is the recent thing in this robot is the robot can feel the experience the feelings. So this is also one of the best machine learning, application, where the robot will be trained with the past data, and whatever the data that we are feeding into the robot, it is getting trained and the model is being created. And when we ask any question with this robot, it will be able to answer. So this is one of the example for machine learning field. So the diagram which I am showing is a traditional programming. How the traditional program, so when we give a data and we give a program to the computer will run, or it will compile, or it process the program, and it will gives you the output. And the next one we are saying is a modern programming, like we give the data and output to the computer, but the computer will give you the program as an output. So this is the difference between the traditional and what the programming that we are going to use it now is a difference. So now we will discuss about the proper definition of what is machine learning. So when if we want to explain about the machine learning in a single line, learning happens with experience. Learning happens with experience is a machine learning. So it is an application of AI that provides the system the ability to automatically learn from the past experience without being explicitly programmed. So the main aim of the machine learning is to allow the computers to learn automatically without any intervention of the human being or without any assistance of the human being, and it just only it performs actions accordingly. So this is what the machine learning tells us. Then the formal definition from Mitchell, it's a well-posed machine learning. So when we define a machine, a computer program is set to learn. We have three terminologies. Learn from the experience E. Capital E is termed to be the experience E with respect to some class of task. Task is defined with a letter T and the performance is measured with letter P. So if it performance at task T as measured by P with improves with the experience E. So this is a formal definition. This we will see this examples with the HS learning problem. So already we discussed about playing a chess with a computer. So the same example I'm going to explain with a formal definition of machine learning. A task T is playing chess and performance P. How we can take a performance P? The percentage of games that we won against the opponent is P. Performance measure is P. Task is playing chess. And what is the experience E? E is termed as playing practice games against itself. Okay, so these all we are giving a terminology TPE. So the ultimate goal of the machine learning is to improve the performance. So whenever we give any task to the computer, to the machine, we will be expecting more performance, right? So we'll be expecting more performance. So that is what we have. We are going to train the machine to get more performance, accurate performance. That is the main aim of the machine learning. So we will discuss one more example also in the same scenario, autonomous vehicle problem. We are going to classify what is a task, what is a performance, and what is the experience E. So when we take a autonomous vehicle problem, the task T is nothing but driving on a highway or roads using the vision sensor. So I showed one picture of a girl. She is relaxing in the car. And the mode of the car is a autopilot mode, which means that she will not do anything with the car. She will not drive it automatically. Automatically, the machine is trained to drive on the road by using some of the vision sensors, machine learning, artificial intelligence applications. Everything is there. So when we classify that, the T is termed as a driving on a public road using the sensor. And what is the performance? P is classified percentage of the time that the vehicle is involved in an accident is a performance, and experience will be images, a sequence of images and steering commands recorded while observing a human driver. So experience means like we can take the machine that learns from the past experience. So if the vehicle which goes beyond the limit of the speed, sometimes it may crash with the other vehicle. So what one or two times the machine can experience this kind of accidents also. So the machine will be learning the machine will learn. So next time we should not cross the speed limit. So this is what the machine is learning from the experience. So that is termed as E. So this is some of the example to understand the formal definition. To understand the formal definition. Now I'll go back with the previous two slides and I'll explain this. Now you will understand a computer program is said to learn with experience E with some of the task T, and the performance is measured with P. So whenever we give any task to the machine will get experience and it has to give you the performance. This is very simple to understand about the machine learning. So few more examples also there. Handwriting recognition learning problems. Now I'm going to explain about only the types of machine learning and what are all the examples which comes under the types of machine learning. Okay, so machine learning is broadly classified into three types. One is supervised, unsupervised, the other one unsupervised, and reinforcement learning. So the supervised learning, the machine is trained with the labeled data. So whenever you give any labeled data to the machine, it is called a supervised learning, which is a task driven. It's a task driven. When I say unsupervised learning is the machine is trained with unlabeled data sets. So when we give labeled data set, it is a supervised learning. When we give unlabeled data set, it is a unsupervised learning. What is the one more? The unsupervised learning is a data driven. Supervised is task driven. It will be purely based on the task, and the unsupervised learning will be purely based on the data. And the third classification is reinforcement learning, which is learning from the past experience, learn from mistakes. These are all the three classifications of machine learning. Now I will explain about what are all the different categories that comes under the supervised learning, unsupervised, and reinforcement. Supervised learning is further classified into two types. One is the classification, other one is the regression, and unsupervised learning is classified into dimensionality reduction, clustering, and the reinforcement learning is classified into reinforcement learning. We don't have any classification, we have only the reinforcement learning. So supervised learning classification, from the name we can say classification, which is going to classify something. Okay, so these are all the examples. These are all examples: fraud detection, email spam detection, diagnostics, image classifications. These are all we can take it as an example for the classification. And under the regression, risk management, score prediction. So supervised, the machine is going to train with the labeled. I'm going to give some set of data which is already labeled. Then I'm telling my machine to train this data to learn applying some of these classification algorithm, regression algorithm, and it is going to give you the output. So fraud detection, these are all examples of classification and the regression. Then when we go to unsupervised learning, it's a dimensionality reduction. We have text mining as an example, face recognition, big data visualization, image recognition. So these are all the examples of dimensional reduction. Then the other one is the clustering. We know that which we are going to group based on the biology, city planning, targeted marketing. So unsupervised learning is classified into two types. And then reinforcement learning from the experience, gaming. So games and all, we have to learn from the experience. So for example, we discussed about the chess, how to guess the next move, and we need to learn the best move, like that. Okay, finance sector, the finance we cannot predict, which may go higher, which may go low also. So learn from the experience. Okay, manufacturing, inventory management, robot navigation. These are all the few examples of different types of machine learning. So the detailed study about the supervised learning and unsupervised learning and reinforcement learning, I'll be explaining you in the next video. Thank you.